Hello students, welcome to Edugle. I am Ankita Raj, recently qualified by Neet examination 2022 with 635 marks. Today I am here to discuss these questions of physical chemistry from the chapter Chemical Equilibrium. So be ready with the questions. The question says at 627 degrees Celsius and 1 atm SO3 dissociation as SO3 dissociate into SO2 and half mole of O2. First of all, we have to notice here that the state in which SO2 and O2 exist is in gaseous state. Okay, and now the density of equilibrium mixture is given, and we have to find the Kp for the given reaction and degree of dissociation. Okay, so ready for the solution. Now we know here SO3 dissociate into SO2 and half mole of O2. So initial pressure is 1 atm, which is given in the questions, and initial amount of SO2 and half mole of O2 is 0. After dissociation, I mean to say at the time of equilibrium, SO3 will dissociate into 1 minus alpha. Alpha is the degree of dissociation, and which will be dissociate into SO2 and half mole of O2. After that, we know alpha is equal to capital D minus D divided by n minus 1 into small d. To find the value of alpha we have to know this formula. Okay, so here capital D denotes vapor density at room temperature. Okay, and small d denotes vapor density at particular temperature in the sense according to this question 627 degrees Celsius. Okay, and n is equal to number of mole into which compound it is associated. Here one thing you have to notice that the formula K. So here I want to tell that एक फॉर्मूला होता है हमारा Kp इज इक्वल टू KC/RT का पावर डेल्टा एन. ओके, तो वहाँ पे जो हमारा डेल्टा एन होता है वो वहाँ पे होता है नंबर ऑफ प्रोडक्ट गैसियस प्रोडक्ट माइनस नंबर ऑफ गैसियस रिएक्टेंट. ओके, बट यहाँ पे जो हमारा एन है वो इट ओनली डिनोट्स दैट द नंबर ऑफ मोल इनटू विच द कंपाउंड इज एसोसिएटेड. For example, here SO3 is dissociated into 1 mole of SO2 and half mole of O2. So for this here n is equal to 1 plus n is equal to 1 plus 1 by 2. Okay, that is 3 by 2. Okay, now according to the question temperature is given 627 डिग्री सेल्सियस, जिसको हम लोग कैल्विन में कन्वर्ट करेंगे तो 900 कैल्विन आएगा हमारा, एंड प्रेशर इज़ 1 atm एंड आर का वैल्यू क्वेश्चन में है हमारा 0.08 and density is 0.8. Okay, so this question is related to the vapor density, so we have to find firstly molar mass of the mixture at particular temperature so that we are able to find the vapor density of at a particular temperature. Okay, so we know D is equal to Pm by RT from ideal gas equation. So molar mass we can find dRT by P. Okay, and density is equal to 8 by 10 into value of R which is given in the questions 88 by 100 into temperature 900. On solving we get 57.6. Now from the equation we are able to find molar mass of mixture at 900 Kelvin 57.6, which after approximation we can write 58. And now vapor density we know molecular mass by 2. Okay, and we denote this in by small d. Okay, small d, and here small d is that one which is written in formula, so don't confuse in capital D and small d. Okay, now molar mass of SO3 at room temperature is 80 we know, and vapor density what will be molar mass by 2, that is capital D is equal to 80 by 2, that is 40. Now SO3 will dissociate as SO2 plus half mole of O2, and n is equal to 3 by 2, which is previously discussed by me. Now according to the formula we put the values and we get alpha is equal to degree of dissociation is equal to 0.75. So to find Kp we have to write the dissociation equation, that how SO3 gets dissociated. So initially SO3 the pressure of SO3 is 1 atm, which will be dissociated as 1 minus alpha, and now alpha and then alpha by 2. Okay, that is alpha, we put the value of alpha which is 0.75. So 1 SO3, value of SO3 at equilibrium, 1 minus 0.75. SO2, value of SO2 is 0.75 and O2 0.75 by 2. Now, just like as Kc, which will be given in the terms of concentration, we can find here Kp value, because the given here partial pressure represents the concentration. Okay, so Kp will be what? Partial pressure of SO2 into partial pressure of O2 to the power half. I mean under root partial pressure of O2, because the coefficient of O2 is half. Okay, and by partial pressure of SO3. So here we will put the value, we will get answer 3 into 0.61, which will be 1.83. Hence, according to questions number A, we have to find Kp. The value is 1.83 in approximation, and alpha, which means degree of dissociation, the value of alpha is 0.75. Okay, thank you, and like and comment if you don't able to understand, and please subscribe this channel. Thank you.